Today, we're going to talk about silica dust and the safety measures that we need to take in order to deal with it. First, let's talk about the dangers of crystalline silica dust. There's been a lot of discussion lately about silica dust in the past few years. OSHA's issued a regulation to help protect workers from overexposure to this dust. It's been largely unregulated in the past. Because of this, many workers have been faced with overexposure to it. The CDC reports that an estimated 1.7 million U.S. workers are exposed to silica dust on the job. Now, OSHA issued its final rule for silica dust on June the 23rd, 2016, but employers have had between a year to 5 years to be fully compliant with the standard, depending on what the industry is. The construction industry needs to be fully compliant now. That is as of September 2017. So we are already to be compliant. General industry and maritime has had till 2018, and hydraulic fracking in the oil and gas industry had a compliance date of June 2021. So we've had this training before in orientation, but let's go over it very quickly. What is silica dust and where is it found? Crystalline silica is an important industrial material that's found abundantly in the Earth's crust. 95% of the Earth's crust is silica. Quartz, which is the most common form of silica, is a component of sand, stone, rock, concrete, brick, block, and mortar as well. So materials containing quartz are found in a wide variety of workplaces. Common industries and operations where crystalline silica is found include construction, glass products, concrete products, foundries, cut stone products, railroad track maintenance, abrasive blasting, and many more. Occupational exposure to respirable crystalline silica occurs when cutting, sawing, drilling, and crushing of concrete, brick, ceramic tiles, rock, and stone products. So what are the health effects? Well, the health effects and the illnesses caused by silica dust are it can be hazardous when very small respirable particles are inhaled. These respirable dust particles can penetrate deep into the lungs. They cause disabling and sometimes fatal lung diseases, including silicosis and lung cancer, as well as kidney disease. Crystalline silica is one of the 119 agents listed as carcinogenic to humans by the International Agency of Research on Cancer. So, as far as our best practice goes, what are the best practices as far as reducing exposure to silica dust? First, we can eliminate the source of the dust, whether that's through engineering controls or change in work processes. We can use collection or vacuum systems to collect dust at the point of operation to avoid suspending the dust in the air. Now, all of the foremen who work for us have HEPA vacs, and those HEPA vacs need to have the filters changed in them. They need to be kept, do need to be properly maintained. So this is what we are doing to try to mitigate this issue. And then also use wet methods when cutting or breaking any concrete or similar materials. When we are core drilling, of course, we're using water that helps lubricate for the cut, but it also keeps the dust down. You can use water as a means of suppression for the dust on roadways or in work areas. Stay out of areas where silica dust levels are high, as well as avoiding being downwind from these areas. Now, this affects what you see being done on sites where there's a lot of concrete mixing going on. You need to be cognitively aware of which way the wind's blowing and how that dust is coming your direction. Using respirators is another possibility. That involves quite a lot of medical procedures. So what we really try to do is to use the dust collection methods and to follow Table 1. So in summary, it's important to understand the hazards that silica dust creates for anyone who's exposed to it. While regulation for silica dust is relatively new, the hazards and the health consequences have been known for decades. Use the engineering controls and the other effective safeguards in order to reduce the amount of this dust in the air so that we can try to reduce overexposure.